Hey everybody, MoNaCo here, Edison Science. It's a first. We're going to try and do your pre-lab and procedures in a video format because your learning responsibility is yours. When I hand you papers, nobody reads them. So you got to watch and listen and write so that you get down the background, purpose, and the procedure for this lesson and this lab, because unlike in previous labs where I hand you the paper, say, read the background, come on in, don't follow your procedure, Mr. What do I do, Mr. What do I do? Now you will know ahead of time and will be showing us that you're ready for lab and responsibility ahead of time. Second half of the year, stakes get bigger.
Who's the us?
Mr. Milks and Mr. MoNaCo. Oh, you forgot to introduce
hey
yourself?
guys.
Sorry,
Well,
bro.
Sorry, Brody. I'm here.
Let's get on with it so that you're not watching me
Cool.
forever and
Yeah,
start
background.
doing background and notes. So cooling curves, we already did some lessons on this, but they show you the changing temperature over time. It's a graph, okay? And this is about interpreting graphs. When you graph that change of temperature versus time, you can find the freezing point of a substance. Which substance? Any substance. For this particular lab, we're doing this stuff called stearic acid. It's kind of this milky, kind of waxy substance. We don't usually do things other than water on paper. So this is a nice experience of finding a real freezing point. Okay. A cooling curve is going to look like this. You know, in this case, in this scenario, we're not going from the gas phase to the liquid to the solid. We're only going from a liquid to the solid. Okay.
So we should only have the two slants and the one flat,
right,
instead of the three slants and the two flats from the notes.
Right. And the other thing is that in this scenario, since it's an experimental procedure, you're actually probably going to get a little weird fluctuation here, maybe even a tail off at the end. All right?
Might not be perfectly flat.
It's not expected to be perfectly flat. If it is, we're going to go, The freezing point of the stearic acid, which is a wax, I know it says acid, but it's a different type of acid. It's an organic acid. We'll get there later in the year. Will be the temperature where your graph is the flattest. We're looking for 2, 3, 4 data points
Wherever it flattens
in a
out.
row to be like, oh, when you're plotting, well, look at that. These 4 data points, it looks pretty flat, Mr. MoNaCo, Mr. Milks.
Somewhere in there is your...
Probably the technical freezing point of the substance.
There you go.
So the purpose, determine the experimental freezing point from a cooling curve. So interpreting data that you collected yourself is one of the purposes. And the next part, analytical purpose, is to compare your results to the accepted results and find your percent error. Tells you how well you've done the procedures, how careful you were in the lab. So next page, you're going to go to the procedure part. And this is what you got to do. If the samples are not already melted, meaning if they look like this, white, waxy kind of substance, you can't get a thermometer in there because it's solid. So you got to melt it first, which you put it into a boiling water bath. If it's not already done for you, you'll have to do that. And then you put your thermometer into it. Got to get it hot, up over about 80 degrees Celsius. Okay, I'm going to turn this one off right now because we aren't going to need it after this. Next thing you got to do is you got to set up a data chart to collect the temperature versus time data as your sample melts if it isn't melted already. You're going to do a lot more than 3 data points, maybe up to 60 data points. So if you can't fit it in this page, get some lined paper, do it there, attach it to the lab at the end. There's an example, time versus temperature, which you got to collect. So when we get into the ring stand, you need to have it set up like this. You got a ring stand with a thermometer clamp in it and a beaker with some cold water. Okay? You're not going to need that right away, but you will need it after a certain point, so you got to have it ready ahead of time. We want cold water. How cold? As cold as you can get it out of the tap. Now, remove the melted sample from the boiling water and begin recording temperature every 30 seconds while you stir. So, as soon as everything's all set up and ready to go, you're going to take it out of the boiling water, start stirring nice and gentle, and you and your lab partner, every 30 seconds, look at the clock, record the temperature. Every
So
30
somebody
seconds.
should definitely be the timer person.
Sure.
Somebody's the stirrer
Every
person.
few minutes, maybe hand it off. Okay, if your hand gets tired or something like that, record the temperature every 30 seconds. As you can see, the temperature's already starting to drop rather quickly. That's good. Now, when do I get to use my apparatus, mister? Well, after your temperature gets to about 60 degrees Celsius. So when your temperature gets low, you'll notice that it's going to slow down as it gets closer and closer to the freezing point. You'll also notice that the sample starts to look like it's forming a solid. You'll put it into the water bath. This is not currently at 60,
Just do it anyways.
but this is what you will do. You'll put it in there, you'll use the thermometer clamp to kind of hold your thermometer in place, and you will let it sit. You're going to stop stirring at this point, but you will continue to collect your data every 30 seconds until the sample gets down to about 40 degrees.
Right, so make sure that thermometer is in a way, put in there in a way you can read it.
Oh yeah, for sure. Yeah, don't lock anything in. You want it to be cooling down as it goes.
Right. Now the main reason why we're going to do this stuff is a wax, and you're going to eventually not be able to stir it anymore without breaking the thermometer.
That's why we want you to stop stirring once it gets down to about 60, because that's getting close to the freezing point. Hint, hint. It's not the freezing point, but it's getting close to it.
Right.
So at that point, with the cold water bath, it'll speed things up a little bit, and your thermometer will quickly get locked into place, which is why it's in a thermometer stand. You may have to replace the cold water after about 5 minutes. I don't think so. But in order to get down to about 40 degrees, you might have to replace it. So
Right.
This could take up to about 30 minutes. So leave space on your data chart to have all that extra data, okay?
Yep.
The graphing your data and determining your experimental freezing point is your analysis part of this lab. And so you're gonna have a cooling curve that will interpret and for your own results at
Right.
this point. Anything else to add, Mr. Mills?
Yeah, the only thing I don't see on that screen right now is cleanup procedure, which is going to be pretty easy. You're going to take this test tube,
So you clean it up. This
Yep.
will be stuck in place. This will be solid.
so
by the
don't
way.
try and move it.
Look, actually, it's already a little, it's hard for me to pull out.
Yep,
So you put it back into hot water.
done.
Done. Or if you're the last lab of the day and Mr. Milks or I tell you, listen, put them in the rack. The thermometers will be stuck in there. That's fine. We'll deal with that later.
When everybody's done with the lab.
Empty the liquid. Break down your setup. Mop up your lab table. Make sure you're off on your hot plate and unplug.
Done.
Done. Thanks, everybody.